What's going on, guys? Let's do this problem right here. The question is asking this series converges or diverges. So let's see how we can use integral test to see whether this one converges or diverges, right? So that's the thing we are going to do. So first, let's write this one in terms of integral. So here the limits of integration is going to be same thing as the summation notation. That's 1 to infinity. So this is going from 1 to infinity, right? So instead of writing n, we replace this one with x. So this is going to be x e power minus x square, right? So this is what we have. So the next thing is, in order to do the integral test, there should be two conditions it has to satisfy. First, first one is it has to be positive, and the second one is it has to decrease, right? And since this is 1 to infinity, we know this is definitely going to be a positive number, because if you plug a positive, like if it's negative, we know that's going to be negative. But if it's positive number, for example, this is going from 1 to infinity, right? Anything above 1 is going to be a positive number, right? So here, if you plug 2, and this is minus x square, since it's a square, this is going to be a positive value. So the whole thing is always going to be positive. So we can justify that it satisfies the first condition, so it's always positive. And then to show whether it is decreasing, you can intuitively say, like for example, if it goes like 1 over 1, 1 over 2, because e over x square, as it increases, the value is decreasing, 1 over 3. So you can use this one to determine whether it is decreasing. But there's another way to do this one. Like, we have to take the first derivative. If you remember, if you take the calculus 1, you may remember we take the first derivative and find the critical points, and then we find the values after critical points and determine what is whether it is decreasing or increasing. If it's positive, it's increasing. If it's negative, it's decreasing. So let's use that technique to figure out whether it is decreasing or increasing. So all we have to do is we have to take the first derivative. So let's do the first derivative. First, I write this one as a function to do the first derivative. So we can say f of x is equal to x e power minus x square. And if I do the derivation for this one, this is going to be a product rule, right? Since we have two different variables, this is going to be a product rule. So the first one is going to be just 1. If we do the derivation for this one, this is going to be just 1 times e power minus x square. And if I do the derivation for other one, this is x is going to remain, and I do the derivation for this one. And for this one, e power anything is going to be remain the same, but there's a chain rule is going to be there, like x times e power minus x square times the inside derivative, that's going to be minus derivative of this minus x square, that's going to be minus 2x, right? So minus 2x, and that's going to be the inside derivative. And now see, go ahead and see what we can do. Let's multiply this x together. So this is going to be e power minus x square plus e power minus x square minus 2x square, right? And if you notice, we can take the e power minus x square common. So if we take the e power minus x square common, this is going to be just 1 plus, actually 1 minus, because we have a minus right here. So this is going to be just 1 minus 2x square. So this is what we get. Now all we have to do is we have to find the critical points. To find the critical points, what we have to do, we have to find this. So we are doing the derivation. So this is original function. Let's put the derivative sign right here, right, f prime x. Okay, so now all we have to do is we have to find the critical points. To find the critical points, there are two conditions. Like, we have to find the situation where x gives us an undefined number, and also we have to equate this f prime x and find the x value. So undefined, we don't have any situation like this, right? And for example, for an undefined, if you have 1 over x, if x is equal to 0, then this situation is undefined. But we don't have any situation like this. So there's no undefined situation. All you have to do is equate this derivative to 0 and find out the x value. And if you equate this one to 0, this function to 0, what value we get? E power minus x square 1 minus 2x square. This one, if you divide 0 by this one, that doesn't change anything, so we can get rid of this one, e power minus x square. So all we have to do is equate this 1 minus 2x square and find the x value. So 1 minus 2x square is equal to 0, and then if you switch this, if you bring the minus 2x square to the other side, 1 is equal to 2x square, therefore x square is equal to 1 over 2, therefore x is equal to 1 over root 2. And that is plus or minus, right? Because it's a square, we are squaring, so it's a plus or minus 1 over root 2. So this is our critical point. Now we have to check whether this one here, this limit is 1 to infinity, so we have to choose only this plus value to check whether it is increasing or decreasing. So all we have to care about is in between this interval, do we get a positive answer or negative answer, right? So here it's going from 1 to infinity, and if we positive half, and if you plug this value above this value, what are we going to get? So for example, I can rewrite this one as, you know what I can do, instead of writing 1 over root 2, I can write this one as, we know that 2 over 2 root 2, 2 is root 2 times root 2, right? Root 2 times root 2 over 2 root 2, and root 2 root 2 cancels, root 2 by 2. So definitely this value is smaller than 2, right? Root 2 divided by 2 smaller than 2. So if we take a value above and check this value whether it is positive or negative, that's going to give us the value for all things, because we have to know what will we get, negative or positive. So let's take 2 and plug in this equation. We have to plug in the derivative that we found. So if you plug 2 for this one, this is definitely going to be a positive number, but let's see what happened right here. 2 square, and this is going to be negative value. Okay, so here we have e power negative 2 square. Okay, this is a negative, and then 1 minus 2x square. 2x square, this is going to be a positive value, positive times negative, that's going to be a negative value, negative, and then okay, here we go, e power x square, 1 minus 2x square. So this is the one we have to look at, 1 minus 2x square, and if you plug the 2 right here, what value we get? 1 minus 2 times 2 square. That's going to give you a negative value, right? So since this is negative, we know this interval is going to be negative value all the way. So this is decreasing. So we prove positive and decreasing. Since we prove these two is right, we can now go ahead and apply integral test. So let's see how we can do this. So first thing is we found the derivative already. We had, since this is an improper integral, we had to use this method that integral 1 to infinity is equal to x e power minus x square. So first of all, we had to integrate this one, right? To do the integration, what you will do, just take this one inside what, x e power minus x square. Here we can do the u substitution. So u substitution, we have to pick up a u value. So if you see that we have the derivative outside, derivative of x is outside, so we can take this one as our u. If I pick u as minus x square, du is gonna be minus 2x, right? But since we have to write everything in terms of, this is actually dx, so since we have to write everything in terms of so we have to put dx everywhere. Let's don't forget that one, right? So since we have to substitute, we have taken care of this part right here. We can do the u substitution here, but instead of this x dx, we have to replace with u value. So to do that, du is going to be this dx and this value. To get this value, I have to take this negative 2 and bring to the other side. So this is going to be du over 2, that's minus, equal to x dx. Now we can write everything in terms of u. So let's write everything in terms of u. So we are going to have integral e power u, and then negative du over 2. I can take the negative half to the front, and then du. If you do the integration for e power u, that's going to be still e power u, right? So that's going to be half e power minus x square. I bring this value back. Actually it's e power u, so I substitute the u again to do the limits of integration. So that's going to be, the limits are going to be 1 to infinity. 1 to infinity. Now let's separate this minus half. So let's take the limit for this one. Since limit x approaches, let's say t. Yeah, t approaches infinity. So for an improper integral, you have to do this one. T approaches infinity, then we plug this one 1 to t e power, x e power minus x square dx. So we already did the integration. Now we can take the limit directly. Limit t approaches infinity minus half common e power minus, let's write this one in terms of t first, then plug that, right? Minus t square going from 1 to infinity. Going from 1 to infinity. All we have to prove is, do we get a finite number or infinite number? Like if we get an infinity, that's divergent. If we get an infinite number, that's the convergent. So that's all we have to prove right here. So here, if you do, let's do the plugging. So here we are going to have what? Negative half, limit t approaches infinity, negative half. If I substitute infinity for this one, e power infinity is going to be 0, right? 0 minus e power minus 1 square, that's going to be just e, right? E power minus, so that's just going to be e. And if I substitute this this value right here, actually it goes like that. For in improper integration, this is going to be, I just made a mistake right here. So all we do is, for an improper integral, we just transform this t instead of this x. So that's going to be e power x square minus e power 1, right? It goes like that, e power negative 1, right? This is our last value and first value. Now let's see what we get, right? So here, if you do the limits for this one, this is going to be half times infinity, e power negative infinity is going to be 0 minus, here we don't have t, so we just can leave it as 1 over e. and if you do the multiplication, that's going to give us plus 1 over 2e. So that's going to be the final answer. Since we have a finite number, we know that this limit converges. So if this limit converges, we can conclude that this series also converges. So that's the main idea. We have to find the limit, like this integral converges. If the integral converges, the series converges. But the thing is, this is not the convergent number. It doesn't converge to this value. We just make sure the limit converges, and to prove series converges, we prove the integral converges. So that's the main thing. I hope you guys find this video helpful. See you next time.